Okay, this is section 5-5, inequalities in one triangle. These theorems are angle-side relationships in triangles. For the first theorem, 5-5-1, it doesn't actually have a name, so the abbreviated version. In a triangle, the larger angle is opposite the longer side. So if we look at AB and say we give it a measurement of 5, for instance, AB is across from angle C, and since that's larger than the length of BC, we'll call that 3, then the angle C must be larger. So if the side opposite is larger, the angle is larger. So angle A is smaller because it's opposite the smaller side. So for 5-5-2, this is basically the same exact theorem. It's really the converse of it, but in a triangle, the longer side is opposite the larger angle. So if it goes one way, it also goes the other. Here's an example of what you can expect to see on a quiz or a test. We need these angles from least to greatest. So pause your video, try it, and I'll give you the answers. So from least to greatest, we have angle H, angle J, angle G. Angle H is definitely the smallest because it's across from the shortest side, 27.2. Here we have to list the sides from least to greatest. So for this missing angle M, if you use the triangle sum theorem, it comes out as 87 degrees. The angles have to add to 180. And then from there, you're going to look at the smallest angle is 39 degrees. So the side opposite that is KM, and you should write that out as segment KM, comma. Then the next side length would be LM, and after that, the longest across from 87 is KL. So this part is called the triangle inequality theorem. Basically, we're saying if we have two sides, like AB and BC, it has to be greater than the third side. And it has to work for all three sides in order for this to be a triangle. So tell whether a triangle can have sides with the given lengths, like 3, 5, and 7. You have to add two numbers, like 3 and 5, and make sure that it's greater than the third side, 7. We were just thinking as a class that if you take the two smallest numbers and do it, then you wouldn't have to check all three. But as soon as you have a no, like for example B, 4 plus 6.5, that's 10.5. That is not greater than 11, so this is definitely no. Once you have one no, the answer is no. In example 3, you take this n equals 3, just plug it in, it's the same thing. You have side lengths of 8, 9, and 6, and this one becomes a yes. Okay, so we have side lengths of 6 centimeters and 11 centimeters, and if this is a triangle, my goodness, 6, 11, we have a third side that we don't know, so I'll call that x. And then we're going to use the triangle inequality theorem. So we take two numbers, like 6 and 11, add them together, and it has to be greater than the third side. So we do that 3 times. And we solve all of these. This is 17 is greater than x, minus 6 on this one, we get x is greater than 5. On the last one, we get x is greater than negative 5, but we can't have a negative side length, so that one's gone. And then we write our answer as a compound inequality, so it's always the smallest number, less than x, less than the big number. This is 5-6 inequalities in two triangles. The hinge theorem is really important. It's saying that if you have an included angle that is large, so the longer side coming from the triangle with the larger angle will be longer than the side in the second triangle across from the smaller angle.